All right, welcome to Chapter 3, Section 1, called Constant Rate of Change. This is for Math 8. So just to go over the screen, as I do on all my videos here, the first thing you will see on your student screen will be a due date. I don't get to see that on the teacher preview, but you will see it on your student screen. Attempts, it's showing me I have attempt 1 of unlimited attempts. This means I can submit this assignment as many times as I would like. I can just keep coming in and trying over and over and over again. We do not limit that. Number of questions, this just tells us how many questions there are in this particular assignment. So it depends on the section we're in. There's going to be anywhere from 1 to 10 questions. Grading policies, best score. That means whatever attempt is the best one is the one you get to keep. Partial credit is enabled, meaning that if you answer 1 of 4 questions, you get credit for the 1 question. This little announcement down here says, please remember, once you start the homework, you must finish it before you can work on anything else. So this means if I click start here, on your student screen, this is the other piece that you won't see, but I do get to see, that you will see, but I don't see on my teacher screen, I said that funny, is this submit assignment button down here in the bottom right corner. So whenever you are ready to leave the screen, whether or not you have finished the assignment, you click submit assignment. It's going to save your place. It's going to know which ones you already have right and which ones you've got wrong, and it's going to just start you back on the next attempt. This will show your teacher you've been working on it and what grade you have so far. It will also stop the system from locking you out of other assignments, because if you just leave the screen, say you just close the tab, it's going to assume that you want to leave that attempt open, and it's going to lock everything else out. It's going to make you come back to this one. So just good habit, always click submit assignment. All right, so we have 3 buttons on the side here. Explanation literally explains this question to us. So it's giving us the solution to this one. So it's telling you you're going to lose your attempt on this question. It's not going to give you the answer and then let you come and type it in. You'll lose the attempt. You'll have to come in on another attempt to try to get points for this one. But it's a very cool feature because sometimes we're stuck on a very particular problem and we would like to see the solution to that problem. So you can definitely do that. Example just gives you a general example, but it's going to be not so general that it's not going to relate to the problem. It's going to be exactly that problem type that it gives you an example of. So we can see this looks pretty close to what we were just looking at with the 2 tables. So we're going to take a look at the ratio of y to x for each one and make sure it's the same ratio. As long as it's the same ratio, we can call them proportional. So that's exactly what we're going to do on this problem. So you can look through the example, read through it, make sure you understand. You can go and look at another example. This will be a brand new one if I click on it again. And then I can also message my teacher. This will attach a picture of this question to the message so that your teacher knows exactly where to come back and help you. All right, let's go ahead and take a look at this one. So for each table, determine whether it shows x and y are proportional. If x and y are proportional, fill in the blank with a number in the simplest form. So we have, forgot to change over to a pen. 9 and 54, we have 11 and 66, and we have 13 and 78. All right, so in order to be proportional, we need to look at the proportion of y over x. And really what we want to do here is we want to think of, what do I need to do to x? Do I need to multiply, divide, add, subtract? What am I doing here to get from x to y? And so with this one, I can simply just kind of go like this and say, okay, well, what do I need to do here to get from 9 to 54? Well, I'd have to multiply by 6, wouldn't I? And if I tested this and I went 54 over 9, this is the ratio of y to x, then this would give me 6 over 1, because that's what it would reduce into. They can both divide by 9, right? Like this. So 6 over 1. So same thing here, 11 to 66, I'd have to multiply by 6. And again, I could go 66 over 11. These both divide by 6. And, sorry, not 6. They both divide by 11. I'm just losing my mind here. So 66 divided by 11 is 6. 11 divided by 11 is 1. So far, so good. Don't stop just because you found 2 matching. You need to check all 3. So with this one, and if we didn't know right off the top of our head, we could either write it off to the side, maybe just testing. Does this in fact get me the correct answer? 6 times 3 is 18, 6, 7. So yay, that does get me the right answer. It is multiplying by 6 again. So I could also do it this way with the y to x ratio, and I would divide by 13 on both, because that's going to get me 6 and 1. If you didn't know it was 13, you know, the only thing 13 can divide by is 13. So that must mean that 78 can divide by 13. We would just have to try that out if we didn't know, if we didn't test it like this first. So both of these show us this proportion. I'm multiplying by 6 every time. That's my rule. I'm doing that every time. To go from x to y, I multiply by 6. Whatever x is, I multiply. And this is showing me y is 6 times bigger than x. That's what this 6 over 1 means. 6 is 6 times bigger than 1. So with this one, we are proportional, and y is 6 times x. So I can read that here. 6 times x is y, right? Or 6 times bigger than x. So either way, I can read it that way. All right, let's look at the next one here. 8, 32, 9, and 72. So again, I'm going to look here and go, okay, well, 7 to 14, I'd have to multiply by 2. And again, if I did 14 over 7, I'd end up with 2 over 1, because I'm dividing by 7. I'm reducing that as best I can, right? 8 to 32. Okay, well, if I multiply by 2, I do not get 32. So this is telling me it's probably not going to be proportional. I have to multiply by 4 this time. So, and if I go 32 over 8, I would reduce by 8. They can both divide by 8, and I'd get 4 over 1. Well, these are already not matching. As soon as you have one that's not matching, you can stop, because it's not proportional. It doesn't matter if 9 over 72 is proportional to one of these other two. They all three have to be the exact same proportion, or changing by the exact same amount, however you want to look at that. As soon as I have something different here, I go, uh-oh, this doesn't work. It's not proportional. Okay? So we click not proportional, and we check. Perfect. All right, next one. Let me erase this craziness over here. All right, we're going to do another one. Same idea. So exact same thing here. So we have 8 and 24, and I'm flipping my colors, but oh well, that's fine. 12 and 48. All right, so let's go ahead and just focus on the ratio of y over x, because that's how Alex wants you to focus on it. And that, you know, is a direct relation there to rise over run. It's not a perfect one, because it's not actually the change in. It's just, we're just checking to see the ratio, but that's kind of what we're looking at a little bit there. All right, so we have 24 over 8. They can both divide by 8. We're reducing. 8 divided by 8 is 1. 24 divided by 8 is 3. And then we have 30 over 10. So remember, this is the x column, this is the y column. That's why I keep doing, and it's always y on top and x on the bottom. So they can both divide by 10, right? And I can just cross the zeros off, and I'd end up with 3 over 1. And then 48 over 12. So with this one, if you weren't sure right away, you could start to do, you know, multiplication with 12. Well, 12 plus 12, if I did addition, this would be 24. Plus 12 more, that would be 36. Plus 12 more, that would be 48. So this requires 4 12s. So if I divided by 12, I wouldn't get 1/3, I'd get 4, sorry, not 1/3, 3 over 1, I'd get 4 over 1. So this means this is not proportional, it doesn't match. We always want to make sure we go all the way to the end. All three have to be proportional. All right, let's see. 7 over 14, 10 over 20, 13 over 26. I don't know why I'm doing over. I just realized I'm writing fractions. And 26. I did it again. 26. There we go. So we want to look at it the other way, right? 14 over 7, 20 over 10, and 26 over 13. So if I reduce this, it would be 2 over 1. They can both divide by 7. These can both divide by 10, right? For 2 over 1. And then 13, if we tried that, 13 plus 13 is in fact 26. So this would also reduce to 2 over 1, because I can divide both by 13. So yay, all three match. So it is proportional. And this is telling me that y is 2 times, I don't know why I put a 2 there, because I'm thinking 2's. Y is 2 times bigger than X. So Y is 2 times X. And if we tested that out every time, I'd have to multiply by 2 here to go from X to Y. So that's also the relationship here. All right. Erase this guy. Let's see, what's our next one here? For each table, determine whether it shows a proportional, well, X and Y are proportional. So it looks like exactly the same thing, it's just slightly different tables, kind of an idea. So, and I'm going to be a little lazy with this, and I'm actually going to put Y on top. So I'm going to go YX like this, so I can kind of lazily write the equations this way, instead of having to write this twice. And we just want to see, does this in fact, did I do that right? 8 over 48, yeah, okay, I had it right. I wanted to make sure I wasn't switching that around. So with this one, I can reduce by 2, so I'd end up with 4 over 1. I could reduce by 5, so I'd end up with 1 over 5. So these are already different, right? So I can finish this by dividing by 8 here, but really as soon as I noticed that these two were different, I could go, nope, that's not proportional, it does not work. I can just stop there. All right, let's go the same thing. So 4, 10, 16, and then we have 14, 35, and 56. Okay, so let's see. If I divide by 2, I'd get 2 over 7, because they're both even. I know I can divide by 2. These end in 5s and 0s, so I can divide by 5. This came out really sloppy, but I think my eraser's a little too big. It's going to erase a lot. 10 over 35, so it's a little better there. So I can divide by 5, right? So 10 divided by 5 is 2. 35 divided by 5 is 7. And then with this guy, let's see, if I'm trying to aim for 2, I'm going to divide by 8. So 16 divided by 8 is 2. 56 divided by 8 is 7. Ooh, so we got our proportion there. So happy day. So it is proportional, but in this case, it's not a direct relation of like it's 2 times X. So we have to make sure we put the fraction in there of 2 over 7. So it's a fractional proportion instead of just an integer. So it's 2/7 of X, which means I multiply by 2 and then divide by 7 to go from one to the other. So let's go ahead and check. Ta-da! And I think we will have one more of these guys. Okay, so we are checking proportionality on a graph this time. So each graph below shows a relation between X and Y. For each graph, determine whether X and Y are proportional. If X and Y are proportional, fill in the blank with a number. So we're doing the same thing. They didn't give us coordinates, but they actually did, right? They didn't write them out in a table, but here are the coordinates. These are the points. Those are coordinates. So we're just determining if they are proportional. One big thing, and this is visually, we can see this very quickly. You can see it on a table too if they give you the beginning point. But in order for it to be proportional, directly proportional this way, it needs to start at 0, 0. And we're going to test that so that you can actually see it. But that's a big one. If it's not starting at 0, 0, it's actually not going to work out. So let's look at graph number 1. We have 0, 0, and I'm going to do this upside down. Okay. So we don't really test the proportion of 0, 0 because that doesn't matter. 0 over 0, that's going to be it's an undefined. But we have 1 and we have 4. So 4 and 1, which just stays 4 and 1, right? That doesn't reduce. The next one is going to be 2 and 8. And I'm putting them backwards, 8 over 2. So I can reduce this, I can divide by 2, and I get 4 over 1. So these match. Even though the 0, 0 doesn't have a proportion that matches, that's fine. I could even go to the next one and go up here to 12, that's crossing at 3. Well, if I had 12 and 3, that would reduce to 4 and 1 again. Yay! So the proportion does work on this one. So this is proportional, and it's y is 4 times x. So 4 times x there. If I look at the next one, I have 0, and I'm going to do the same thing. So x is, I don't know why I'm doing that. X is 0, and y is 4. Well, again, with this one, if I were to make this a fraction, this one wouldn't work. So we're going to ignore that first one there because it's on 0. So let's go to the next one. It'd be 1 and 7. Well, that doesn't match already. That's kind of a weird one. 0, 0 doesn't count when we do it, but when it's 4, 0, that tells us something. It actually tells us it's not starting at 0, 0 where it's supposed to be. All right, let's look at the next one here. So we'd have 2 and 10. Well, this would reduce into 5 and 1 because I can divide both by 2. So these guys don't match, right? Those are not proportional. They're changing by different numbers. X is 7 times, or y is 7 times x on this one, but it's 5 times x on this one. So it's not working out correctly. And we could even go to the 12 here. Actually, this would be 13. It'd be 13 and 3. So that's definitely not matching at that point. So this guy is not proportional. So remember, proportional means I need to start at 0, 0. Then, as long as it's a straight line, it will be proportional if it's starting from 0, 0. So this guy is a straight line, but it's not starting at 0, 0, so we don't call it proportional. All right, so that was section 1 of chapter 3. I will see you in section 2.